most part.
All right. Hold on, my dog wants out of the room. Let her out. Go on. Go on. Go. I've moved my offices, so the audio might be a little different. I feel like I'm in a little bit of a sound chamber.
That's fine.
I don't know if it sounds different or not. Okay.
It sounds the same to me.
What do you got as a first one?
Okay. 4x squared plus 25 equals negative 75.
4x squared plus 25 equals negative 75?
Yep.
Really? 4x squared plus 25 equals minus 75? Have you had imaginary numbers?
Yeah. No.
You haven't had imaginary numbers?
We haven't learned about them yet. My teacher talks about them, but she said we're not ready for that yet.
Well, this is going to produce an imaginary result. In other words, my first step is to subtract 25 from both sides.
Mm-hmm.
And I'm going to divide both sides by 4. And then I'm going to take the square root of both sides. Well, that has you taking the square root of a negative number, which until you learn about imaginary numbers you can't do. It turns out that that's equal to 5i, where I is equal to the square root of negative 1.
Huh. Okay.
Okay? Now, why is it called imaginary? Because there are no two numbers that multiply to a negative number, right? If you think of
Right.
any number multiplied by itself, it's always going to be positive. So you can't get a negative number. So they make up this concept of an imaginary number that's equal to the square root of minus 1. So the square root of minus 25 becomes, you can always take the square root of minus 25 and turn it into the square root of minus 1 times the square root of positive 25, right?
Right.
Okay, well that's I, and that's 5. So you end up with 5i.
Okay.
Okay?
But in my case, since I haven't learned about imaginary numbers, would it just be no answer?
I suppose. Yeah.
Okay.
No answer. Yeah, that's why I was surprised to see it. Okay?
Okay.
What else?
This one is 19 equals 30 minus 5x squared.
Okay. What's the first step?
Would it be subtract the 30?
Yeah.
Okay.
I mean, I tend to avoid negative numbers if I can. So I would be, let's talk about this for a second. I would be more inclined to move this to the left side and to move this to the right side, because that would leave everything positive. Notice that if we did that, I would have 5x squared over there, and I would have 30 minus 19, or 11, there. Now I got nothing but positive numbers.
Okay.
But there's absolutely nothing wrong with what you did, and in fact, your method only takes one step, although you have to do another step that I didn't have to do. In other words, you're only moving one quantity, this quantity right here, to the other side.
Okay.
So what would be on the left side?
It would be 11, right? Or negative.
Negative 11. That's
Negative
why I
11,
like
yeah.
to avoid negative numbers.
Yeah.
Okay? In other words, in one step, you got to where I got in 2 steps, but there's still another step required here. You have to divide both sides by negative 1 to get this. So you get to the answer the same in both methods, and my method involves fewer negative numbers. So just a thought, when you go to solve these kind of equations, is find the sign on the x term, in this case that negative, let's move this to the other side, that'll turn it positive. Okay, so we get 5x squared equals 11. What next?
Divide by 5.
X squared equals 11 fifths. What next?
Would you square root?
Okay, what's the next line?
Would be x equals the square root of 11 fifths.
Good. Except for one thing you left out. One thing that if only I had a little magic rhyme that I could get people to remember this. Whenever you take the square root of an equation, both sides, always begin with the words plus or minus.
Okay, plus or minus.
Yeah, because let's take this. X squared equals 4. Okay, if I take the square root of both sides, it's plus or minus 2 because plus 2 squared is 4 and minus 2 squared is also 4.
Does this have to do with the quadratic formula?
Not yet. No, I mean, I understand the quadratic formula has that plus or minus, so in a sense it does. Actually it does. You're absolutely right. They developed the quadratic formula by completing the square and doing the algebra. That's how they get it.
Okay.
And when you do the algebra, you end up having to take the square root of both sides of the equation and you get a plus or minus. So that's where that plus or minus comes from. Now we're not quite done.
Okay.
It doesn't look like we have an irrational denominator, but we do. Because this is actually the same as the square root of 11 over the square root of 5. That's not a proper answer. You never want to have an irrational number in the denominator. And whenever you have a radical sign that doesn't convert to a whole number, you have an irrational number. In other words, that's irrational, that's irrational, that's irrational, that's irrational.
So, what do you do in that case?
You rationalize it. You rationalize it by multiplying the bottom by square root of 5. Well, the only thing I can do to a fraction is multiply it by 1 without changing its value. So I have to multiply the top also. Notice that this number is 1.
So do you always multiply it by the denominator?
Yes.
Okay.
So now what do we have? What's the denominator become?
25. Square root of 25, which is 5.
Oh, right. Okay, you got it. Sorry.
Oh, my bad.
Just 5,
Sorry.
yeah. And the top is what?
Square root of 55.
Can I simplify that?
I don't think you can.
No, because it came from 2 prime numbers. In other words, if I multiplied 2 prime numbers to get that, there's no way there's a factor of that that's a perfect square. At least I don't think so. But no, that's definitely simplified. So what we're saying is that this number is the same thing as this number. It just has a rational denominator. So your final answer is plus or minus root 55 over 5.
Got it. Okay, the next one is, in parentheses, x minus 1 squared equals 0.
Okay. What can I do as a first step?
Can't you multiply the what's in the parentheses by 2 and factor? Like
I
4?
could FOIL it out, but here's what I'm going to get. And how do you solve these? by fact.
Right.
In other words, this is going in the wrong direction. That doesn't help, because then I have to factor it to get it back to where I started from. Remember that this means x minus 1 times x minus 1.
Right.
Let's solve it the same way we solved the last one.
Okay.
Take the square root of both sides.
Okay, the square root of 0 is 0, right?
Okay. It's the square root of the left.
So would you square root the entire thing in parentheses or
When the whole thing on the left is being squared like it is now, then we can just remove the 2. That's how you take the square root of it. I mean, it's different if I've got something like this. I can't take the square root of the both sides yet. I got to get that 2 on the other side so that everything on the left side is being squared, and then I can take the square root and just get rid of the 2.
Okay.
So this is x minus 1, and it is plus or minus, but plus or minus 0 is the same number, so we'll leave it like that. So what next?
Plus 1.
And that's the answer, only plus 1. Notice that it's not plus or minus 1. If I stick minus 1 in there, that becomes minus 2. Squared would be 4. So.
Okay. 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 The next one, it says solve the equation using the quadratic formula. Round your solution to the nearest tenth if necessary.
Okay.
And it says x squared plus 2x minus 15 equals 0.
What's the quadratic formula? The general formula?
Yeah. Or quadratic formula, my bad.
We can solve this by factoring, but they specifically said use the quadratic, right?
Yeah. Which is x equals negative b plus or minus the square root of b squared, I think, minus 4 times a times c all over 2b.
2a.
Or 2a, my bad.
That's good. So in our equation, what is a, b, and c?
Okay, a is going to be 1.
B is?
B is 2. And then c is negative 15.
Okay, so let's plug it in. Tell me what to write.
Okay, negative 2 plus or minus the square root of 4, and then minus 4 times negative 15.
Oh, what's a? Okay, okay, I got you.
Yeah.
I'm going to recommend something here that you always do, and that is this. Because it's really easy to get your signs off when you use the quadratic formula. And it's important to understand that these 3 numbers are always being multiplied together. So this is subtraction, that's a negative sign. And that's something else that's easy to make a mistake on. All over what?
2a. Oh, my bad. 2, yeah.
All right, now let's simplify this. What's the inside become?
Let's see. It's gonna be. Does that be? If you multiply negative 4 times 1 times negative 15, it's positive 60, right?
Correct.
Okay. So then it'll be 60 plus 4, so 64, square root of 64.
Right.
Okay.
In other words, it's you can think of it in two ways. You can multiply those three numbers together and get negative 60. But then we got 4 minus a negative 60, which is the same as 4 plus 60. Or you can look at it the way you verbalized it, which was you had a negative 4. That's not really a negative 4. That is subtraction. Now I know that it appears that subtraction and negative signs are the same thing, but in actuality they're not. We're subtracting the product of those three things is what we're doing.
So you're really multiplying positive.
Always think of multiplying these four AC together, and whatever you get, that's going to be subtracted from the first one, B squared. And that's the best way to think about it. And that way you're not ever going to get confused by lots of negative signs. Because A can have a negative sign too. In other words, when you get a whole bunch of negative signs, it's real easy to make a mistake. So the way I would always do it is multiply those three numbers and take whatever that is, positive or negative, and subtract it from 4. All right. And now, simplify further.
Okay, so once you do the square root of 64.
Which is?
8, right?
Simplify further.
Divided by 2. So isn't there like two answers then?
Yeah.
So it'll be x equals blank or x or x equals blank.
So let's do this one first.
Okay. So it's going to be plus 8, so x equals 4. Or, my bad,
minus
6.
2 plus 8, 6 over 2 plus 3.
Is,
that's one solution.
Okay.
Second solution is doing the minus.
So that would be negative 8. Or, oh my gosh, I'm sorry, negative 10.
Over 2?
It's 5, negative 5.
5. Okay. Now, notice that we got integer answers, whole numbers. That means that this thing was factorable all along. We didn't need to use the quadratic formula. If I go back and look at it, it factors really easy. X and X, that means the signs are opposite. We're looking for factors of 15 that subtract to the number 2. That's 5 and 3. I put the biggest one with the plus sign that is there. I put the other number there. My two solutions are minus 5 and plus 3. Same thing I got when I used the quadratic. So you don't generally use the quadratic on something that you can factor just because factoring is so much faster. But if I change this number to a 14 instead of 15, now I can't factor it. And the only way I can solve it is by using the quadratic. So when you have something that can't be factored into whole numbers, then the quadratic is what you fall back on. But only then. I mean, unless the problem tells you to use the quadratic, like there. All right. What else you got?
So this one's different. This is solve the equation by completing the square.
Okay.
It says round your solutions to the nearest tenth if necessary.
Okay.
So x squared plus 6x minus 40 equals 0.
All right. Solving it by completing the square is a little different than normal. And that normally we solve quadratics by always getting 0 on one side.
Okay.
Well, with this, I suppose you could do it with leaving the 40 on that side, but eventually you got to move it over, so let's do it right away. Now what I've done is grouped the x squared and the 6x together, and this is what I want to complete the square on.
Okay.
You know how to complete the square?
I think you take like the b value, right?
Take the coefficient, yeah, b, You take half of it and square it, and always add it.
Yeah.
Because even if it's a negative number, once you square it, it's positive. So what do I write here?
So see, if you divide that by 2, you get 3. It's 9, right?
Correct. Since I added 9 to the left side of the equation, how much do I have to, what do I have to do to the right side of the equation to balance?
You have to do minus 9.
No, you got to do the same thing.
Oh, plus 9.
If I was doing it to the left side, I would have to minus it. But if I'm doing it to the other side, I got to do the same thing. Okay? The key thing is you can't change anything. And I haven't. I can subtract 9 from both sides right now and get back exactly to where I started from. And it's always kind of a good idea to check that as you go along, to make sure you have not changed anything. The purpose of completing the square is I can now write this in a different way. I can write it as x plus 3 squared. And you can always do that. In other words, you can always turn it into a linear factor that is squared. And that's what happens by the method that you use to do it. Well, now we're looking at that. Now, I can solve this because the entire left side is being squared. So what's the next step?
Divide.
Square root.
Oh, my bad, square root.
Okay, so take square root of both sides. What do you get?
Okay, square root of, oh, so my bad, it'd just be x plus 3.
What are the first words supposed to be out of your mouth?
First words, plus or minus. Square root of 49. I don't think I know square root of 49.
7.
7.
Okay. So we're not quite done. What's next?
Okay. Let's see. This one says find the number of x-intercepts of the graph.
Hold on, we're not done with this problem.
Oh, my bad.
Okay.
My bad.
We need to solve for x, so there's a couple of more steps.
Okay. Would you subtract 3?
Okay.
Both sides.
Equals what?
Equals plus or minus 7. Or minus 3.
Okay, now we have to translate that. In other words, you don't want to leave an answer like this. This means two different numbers. What's the first one?
Can't you just subtract the 3 from the 7? Or
yeah, the first one is the plus. So what happens when you put plus 7 minus 3? What do you get?
Oh, okay. So my bad. You get 4, right?
What happens when you do minus 7 minus 3?
You get negative 10.
Okay. So, again, we got integer answers, which means we could have factored this one also, which would have been a lot easier than completing the square.
Got it.
X, opposite signs, factors of 40 that subtract to 6, 10 and 4. Put the 10, the bigger factor, with the sign of the middle term. The 4 goes there. You get the same two solutions, minus 10 and plus 4. So, you do have to know how to complete the square, and there's a lot of time where there's problems that's the only way to solve it, is by completing the square. But both the last two, we could have solved them easier by factoring both of them. So what's this next one?
It says find the number of x-intercepts of the graph.
Okay.
Or, yeah, of the graph of the function.
Okay.
So it says y equals negative 1/2 x squared plus 2x.
Okay, that's going to graph to some kind of a parabola that's pointing down, right? Now, I don't know if it's there or there or there, but there's two places where it crosses the x-axis. Let's assume it's this one.
Okay.
What is y when it is at both of those places?
0.
Now solve that equation.
So,
in other words, that's the way you get x-intercepts, is by always setting y equal to 0,
okay.
and then you solve for x.
Would you, so, oh, okay, so you would do, like minus 2x?
Well, actually not.
Okay.
Let's talk about that. I don't know if I want to get into that. Yeah, let's talk about that. If I had minus 2x equals minus 1/2 x squared, you might then be tempted to divide both sides by x,
Okay.
which gets rid of that and turns it into minus 2 equals minus 1/2 x. Now you multiply by minus 2 to get x equal 4. That is a solution. But because we divided by a variable that might be 0, we're going to lose that solution. And we did. We didn't come up with 0 as a solution. We came up with just 1, 4. So that's not what you want to do when you have this. Let me show you what you want to do.
Okay.
You want to factor out an x. In other words, you want to try to take out the greatest common factor. That leaves minus 1/2 x plus what?
Plus 2x.
Okay. Now all of that's equal to 0. Now we have the classical quadratic solution. We have two things equal to 0. One of them has to be 0. So we set both of them equal to 0. Well, that includes that. So there's one solution. And then we set that equal to 0. And that provides the solution x equal 4. So by doing it by a factoring, you get both solutions. You don't lose one of them. And that actually is true from here forward in mathematics, that if you're dividing by variables and 0, it could be 0, then you're going to lose that solution. So you don't generally want to do that. It's okay to divide by constants, both sides of an equation. But dividing by a variable has its dangers.
Okay.
Okay? So what that means in our picture was that our two spots that it intercepts the x-axis are there and there. It must be this kind of parabola. So in this case, losing the 0 would have been really costly because we would only had one answer and we wouldn't have known what the both x-intercepts were.
Okay.
Okay. Connor, I'll go as long as you need to. I thought I'd be tired. I'm on about my 6th hour, but you got more to do. I'm willing to keep going.
Really?
Sure. Yeah, I don't mind.
Okay.
I mean, we can do that, or we can end it and you'll have a half-hour credit coming because your mom has paid for an hour. But you're certainly entitled to take a half hour at a different time if you'd prefer.
Well, how long are you willing to go to?
Well, I can go a whole other half hour. We can go to 9:30 if you want.
Okay, yeah, I'd really appreciate that. Okay. So, you want to do another one of those then?
Whatever you like.
Okay. This one is y equals 2x squared plus 4x plus 8.
Okay. And I'm looking for the x-intercepts, right?
Right.
So work me through it.
Okay, so y is equal to 0. And then don't you want to factor it?
You do, but there's something
Okay.
you can do first to make the factoring simpler.
That is...
Remember, it's always simpler if you're dealing with just an x squared. Those are a piece of cake. You know, you just have to apply the 3 rules to it, and you can't go wrong. The only problem factoring is when there's a coefficient in front. So is there anything we can do to get rid of that 2?
We can divide.
Yeah, we can divide both sides of the equation by 2. We're going to do that, we're going to do that, that, and that. Well, 0 divided by 2 is still 0. This becomes x squared plus 2x plus 4. Now, I said factoring was a piece of cake. Let's try to factor that.
Okay.
What are my signs?
Plus. And then won't it just be 2?
Well, we're looking for factors of 4 that add to the number 2. Here's the factors of 4. Do any of them add to 2?
No.
Okay, this is one we have to use the quadratic formula to solve. In other words,
Okay.
it is very easy to factor these if they're factorable. But it's also very easy to determine they're not factorable pretty quick.
Gotcha.
So it's worth giving it a shot at factoring it. Giving up. Now we'll go to the quadratic. Tell me what to write.
Okay. It's going to be negative 2 plus or minus the square root of 4 minus 4 times 1 times 4 over 4. Oh, my bad. 2. My bad.
Simplify.
Okay. So it's going to be negative 8. Would it be negative 4?
Hold on.
The square root of negative 4?
No. Oh, excuse me. No, not quite. Multiply those 3 numbers together.
Okay.
Without this sign.
Oh, my bad. It's going to be 16.
What's 4 minus 16?
Is 12.
Negative 12.
Negative 12. My bad.
Okay. All over 2. This is a complex number, an imaginary number. What that translates to is there aren't any x-intercepts. Whenever you have and we only have complex solutions. We don't even have a real solution, which means the parabola is below the x-axis and doesn't go through the x-axis, is what it means.
Okay.
So whenever you have the graph looks like this, or like this, or like that, all of these are not going to have x-intercepts, which means that when you plug it into the quadratic, you're going to get imaginary solutions.
Okay.
Okay? Well, yeah, if the question was find the x-intercepts, then the answer is there aren't any. If the question is solve the equation, well, this is the final solution. Let me just go ahead and give it to you. because if you haven't had imaginary numbers yet, you're certainly going to get them soon. This would simplify to, first of all, the square root of minus 12 is always start these by taking out the negative sign, by doing that. And then that leaves square root of 12, which is the square root of 4 times the square root of 3. So that's 2, that's I, and that's square root of 3. So you generally write it like this. Okay, so the final answer would be minus 2 plus or minus 2 root 3I, all divided by 2. You can divide top and bottom by 2 and make all of those be 1s. You see how I can do that?
Right.
In other words, you can always divide the top of a fraction and the bottom by the same number, but it doesn't make it go to 0, it just makes it go to 1. I don't need to write these two 1s, I need to write that one. So my answers are minus 1 plus root 3I and minus 1 minus root 3I. And complex answers always come like that. They're always conjugates of one another. So if somebody says one of your answers is this, then you know another answer is this. Always. They always come in pairs.
Okay.
All right. What else you got?
This one says simplify the expression.
Okay.
So the first one is square root of 72p to the power of 7.
Okay. Let's take each of these separate. Let's talk about this.
Okay.
I was going to separate that into two things. Remember, one of them needs to be something that can come out of the radical sign. What
Okay.
if I did this? What's the square root of p to the 6th?
P to the
3rd.
Okay.
Without the radical. I got it outside the radical. I still have that inside the radical. So this is what it simplifies to. So when you're taking the square root of a variable to an exponent, you got to turn this into an even number. If it's already an even number, then you don't need to do anything to it. But if it's an odd number, you need to do this process here. Okay? Now, the way to handle the rest of it, you always do these one thing at a time. You do the constant, the number part, and then you do the first variable, second variable, third variable, however many there are. You just do them one at a time. So let's simplify this.
Okay, square root of 72.
Huh?
It's 9. No.
We're looking for factors, one of which is a perfect square. So let's go through the perfect square numbers. 1 is a perfect square number. 4, what are the rest?
6.
No. In other words, this is
8.
1 squared, 2 squared, what's 3 squared?
9.
What's 4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
7 times 7. 40. 49. Okay.
8 squared?
64.
9 squared?
70. No, my bad. 81.
10 squared?
100.
Okay. Those are your perfect square numbers. And it's good to know these, because we need to find one that divides into this.
Okay.
Now we have a couple that do. 4 does. But if we can get the biggest one that does, it'll simplify the problem quicker. Well, 36 does also. So I can turn this into this. And now that becomes 6 root 2. So you're always looking for a factor of that that is a perfect square number. Now, let's go back and assume that we didn't know 36 was a perfect square number, but 4 is. I can turn this thing into 4 times 8. Excuse me. 4 times 18. Okay? This will still get us to the right answer. It'll just take longer. Because the 4 comes out as a 2, but then the root 18 simplifies into root 9 times root 2. Root 9 is a 3. 2 times 3 is 6, root 2. So you still get to the answer, it just takes an extra step. In other words, you kind of break it down in smaller chunks.
Okay.
And that's okay. You don't have to immediately identify the greatest factor that's a perfect square. You know, you can almost always start with 4 or 9. Usually those are going to be divisible into it if it's simplifiable, that is. So that is 6 root 2. And the other was p to the 3rd root p. Put them back together again, what do we get?
Square root.
Now let's start with the number.
The 6 and 2.
Excuse me. Let's start with, these are being multiplied together.
Okay.
I don't know why I wrote it the way I did. I should have wrote it like this. Now, because we're multiplying, let's put the number, everything outside the radical together, and everything inside the radical together. So there's your answer.
Okay.
You got some more of those? Because it's good to practice some of those.
Yeah. The next one is, it's like the power sign 3.
Okay, this is the cube root.
Cube root, okay.
That matters, how we're going to do the rest of it. Go ahead.
And on the inside, it's 125x to the power of 11 over 4.
The 4 is inside the radical?
Yes.
Okay. Again, we're going to take each one separately, but again, let's start with the variable.
Okay.
The cube root of x to the 11th. We want to turn that into something where the cube root comes outside the radical, and that would be x to the 9th, leaving the cube root of x squared. And you see why we make it to the 9th? We want the biggest multiple of 3 that we can get. Just like when we were doing square roots, we wanted the biggest multiple of 2 that we could get. Biggest even number. Well, we don't want the biggest odd number. We want the biggest multiple of 3. And in this case, that's 9. Because I can turn that into what?
You can turn that into a,
That is x to the 3rd. When you take the cube root
Oh,
of x to the ninth, you get x to the third. Remember what the cube root is. It's x to the third times x to the third times x to the third. When you're multiplying same base, different exponents, you add the exponents. So those three things, or that thing multiplied by itself 3 times gives you x to the ninth.
gotcha.
So when you're dealing with cube roots, it's a little different. Okay, so this part becomes that, and that's the way we would express the rest of it as the cube root of x squared. So now let's handle the number part. Again, let's do it separately. I'm getting messages telling me I've lost my audio. You hearing me okay?
Yeah, I hear like a fuzz in the
A
background.
little static? Okay.
Yeah.
It's the first thing I need to do to this.
Divide the 125 by 4.
Don't want to divide that number by 4. That'll give me a decimal, and that won't help.
Okay.
But what it does is it becomes the cube root of 125 over the cube root of 4. What's the cube root of 125?
5? No.
Yes.
It is 5.
Uh-huh.
Okay.
Only positive 5, incidentally. When you take square roots, you're always plus or minus. But cube roots are always whatever the sign is inside. And you can take the cube root of a negative number. There's nothing wrong with that. When you take a negative number and multiply it by itself 3 times, it's negative. So, but 5 times 5 times 5 is the only thing that produces 125.
Gotcha.
Now, I'm not done because I got a 5 up there and I got this irrational number down here. I guess we need to rationalize. When you rationalize numbers that are cube roots, there's a better way to write it. That's the same as the cube root of 4. Okay? So if I had 5 over 4 to the 1/3, the way I can rationalize it is, what do I have to multiply the bottom by?
4 and 1/3. Or to the power of 3, right?
What exponent will turn this into a rational number? It's a little tricky. It's 2/3.
Yeah. Oh, okay, because I was going to guess that, but...
that turns the bottom into 4, because it becomes 4 to the 1 power. Well,
okay.
Multiply the bottom by 2/3, we got to multiply the top by 2/3. Okay, now what results is 5 times 4 to the 2/3 power all over 4. And that's what our answer is going to be. And we can write it a little different. In other words, we're going to write 4 to the 2/3 this way. When we put it back inside the radical sign, looks like that. This 4 is 4 to the 2/3 power. Okay? So, again, putting everything back together, the number part becomes 5 times 4 to the 2/3 over 4. 5 over 4 to the cube root of 4 squared. And we've got an x to the 3rd out here. And we got an x squared inside. So a little prettier way to write it, if I put the number first. Okay?
Awesome. Okay. This one says determine whether the quadratic function has a maximum or minimum value.
Okay.
Then find value. So I'm sorry, my bad. The first one up is f of x equals x squared.
Another thing, same thing as y.
Okay. Plus 4x plus 11.
And what's the question? To determine whether this thing has a maximum value.
Maximum or minimum.
Okay.
And then it says then find the value. So.
What is this shape? What are quadratics?
Parabola. Parabola.
Okay. And they're either parabolas that point up, so you would have a minimum, or they're parabolas that point down, so you would have a maximum. Okay. So, first of all, if the coefficient of the x squared term is positive, it points up.
Mm-hmm.
So we know that it has a minimum. Even if it's imaginary, it has a minimum. In other words, if this was the graph, that wouldn't have real solution. Doesn't cross the x-axis, but it doesn't matter. It would still have a minimum. Its minimum value would be that value right there. But it could be below the x-axis, and then its minimum value would be that value right there. Okay. Now, in terms of labeling the axis, this is still the x-axis, and this is the f of x-axis. So, you must have been taught about the vertex of a quadratic.
Yes.
And it's at the vertex where that minimum takes place.
Right.
So we need to find the vertex. So when you have a quadratic in standard form, which is what this is, there's a formula for the vertex, for the line of symmetry, which is the x-coordinate of the vertex. Know what it is?
The vertex.
It's the first part of the quadratic formula.
Okay.
Notice the quadratic formula. It's that part right there.
Okay.
So if you got this memorized, it's easy to memorize this. And if you got this memorized, it's very helpful for remembering the quadratic also.
Okay.
So let's figure out what the x-coordinate is. What is it?
Okay, so negative b is negative 4 over 2. So 2 or negative 2, right?
So our line of symmetry goes right down negative 2. There's negative 2. We'll draw a dotted line to represent the line of symmetry. So we know our parabola is somewhere on there, but we still don't know where the minimum value is yet. We're looking for f of x when x is negative 2. So another way of saying that is, what is f of negative 2? That's going to give me my f of x value. And then it's the y-coordinate of the vertex.
Okay.
So how do I get it? What does it mean, f of minus 2?
Doesn't that mean that the x value also has to be negative 2?
Yeah, it means substitute, whenever you see x, substitute negative 2 for it.
Okay.
And it's best to write it exactly this way and then simplify. Reduce these mistakes. Okay, what next?
Okay, so negative, that's going to be 4 plus 4. So would you multiply the 4 and then the negative 2,
Yeah,
or would you
I
multiply
would
the
just
negative
do
2?
this, minus 8.
Okay.
Because that times that is minus 8, and when you have a plus and a minus together, you just drop the plus.
Okay.
Okay, plus 11. Simplify that.
Okay, it's going to be negative 4. It's going to be positive 7.
Okay. Let me just give you you might have done this in your head. The best way to do this is to add the positive numbers together first. 4 plus 11 is 15, and then you got 15 minus 8. In other words, you can avoid going through the negative number. If you do this step first, you get minus 4, and then you got to do minus 4 plus 11. Again, avoid negative numbers if you can.
Okay.
That tells me that my y-coordinate of the vertex is at 7.
Mm-hmm.
So there's the vertex right there. We know it goes up, so the minimum value is 7.
Okay.
And notice that it goes up, so there are no zeros. The thing does not cross the x-axis. Which means that if we had to solve this equation, make that equal to 0 and solve it, we're going to use the quadratic formula, and we're going to get I in our answers.
Okay.
All right. It's 9:31. You good to go, you think?
Yeah, I'm good.
Okay. All right, Connor. Have a good one, and good luck on your quiz.
Thank you very much.
All right. Talk to you later.
Okay, bye-bye.